Hello, dear students. Let us to discuss the practical application of this Redstone's network. Okay, so this Redstone's network is consisting of four resistors R1, R2, R3, and R4. In previous class, we have already discussed it. And by adjusting the values of R1, R2, R3, and R4, to get the current flowing through the galvanometer becomes zero, then we can say the bridge is balanced or the network is balanced. And under the balancing condition, R1 by R2 equal to R3 by R4. Okay. So now let us to discuss the use of this Redstone's network. Okay. See, this meter bridge is the device used to detect or used to measure the resistance of unknown resistance. Okay, so the resistance of the unknown resistor, or simply the resistance of wire. Okay, see, between A and C, I will draw here, between A and C, this one is A, this one is C, A and C. Okay, instead of two resistances, R1 and R3, we take 1 meter wire. This one is the 1 meter wire which is connected between A and C. Okay, so now and this 1 meter wire is having some resistance. See, and this wire 1 meter is usually fixed on a meter scale to measure the length. Okay, so now between A and C, a battery is connected. Okay, this one is the battery connecting between A and C. Okay, so this one is fixed on the meter scale. Okay, now between A and C, two more resistances R1 and R4. Okay, this is one more resistance. This is another resistance which is connected between A and C. So instead of R2, I will say this R, and instead of R4, I will call it as S. Okay. So between R2 and R4, there is one point B. I will take this point as B. And between R1 and R3, D is there. Okay. So here AC is two resistances, R1 plus R2 itself is the resistance of the wire AC. Okay, I will take one galvanometer which is connected between B and D. I will connect, or I will touch the one end of the meter here. I will call it as D. Let its length is, the length of the wire AD is L, and clearly this length is 1 minus L, because the total wire length is 1 meter. So for example, it is 30 centimeter, clearly it is 70 centimeter, and this one is the battery and the key. Okay, see how to measure the resistance by using this 1 meter wire, and this arrangement itself is called as the meter bridge. Okay. Now touch, when the plucky K is closed, some current is flowing through the network. Okay, and galvanometer showing some diffraction. If you touch the one end of the galvanometer, that one is called as jockey, to the wire is, it will be showing some diffraction, and you have to adjust the length in such a way that it will show zero reading, means null diffraction. So it means the network becomes balanced. The network becomes balanced. Okay. So suppose for some particular length the network get balanced or bridge is balanced. If the bridge is balanced, okay, that can be identified by using the galvanometer. Then the condition is R1 by R2. R1 by R2 equal to R3 by R4. R1 by R2 equal to R3 by R4. See, from this relation or condition, okay. See, when the galvanometer shows zero diffraction or null diffraction, then we can write from this as R2 by R1 equal to R4 by R3, or R2 equal to R1 upon R3 into R4. You can write R1 by R2 or R2 by R1. Okay. See, now you have to apply the same condition for this network also, same arrangement. So here instead of in place of R2, R is there, and in place of R4, S is there. So I will write it as R equal to R1. R1 means resistance of AD. R3 means resistance of DC, into R4 means the value of R4, or in place of R4 the resistance is, we can call it as S, or standard resistance S. Okay. So now R equal to resistance of AD. We have already known the resistance is directly proportional to length and inversely proportional to cross sectional area. Okay. See here, both wire, that is AD and CD, having the same material, it means the resistivity is also same, and same thickness means even cross sectional area is also same. Only the difference is length. So the length of AD is L and length of CD or DC is 1 minus L. So therefore resistance equal to length into specific resistance, or resistivity into length divided by area. So resistivity of both will get cancelled and even area of both will get cancelled. Only the ratio of resistance is same as the ratio of length will get. So that we can write its length is L, its length is 1 minus L. So into S. Okay. So therefore we can write the unknown resistance R equal to S into L divided by 1 minus L. So what it means, simply by adjusting the length to show null diffraction, so easily we can calculate the resistance of the wire. Okay, if this one is the standard resistance, or you have to use the resistance box here, so it means this resistance is known, so easily we can find this resistance within fraction of minute or within 1 or 2 minutes. So we get the resistance of this unknown resistance by using this simple arrangement. So this is the most valuable experiment, because easily we can measure the resistance, as well as it has many applications. We can also measure the EMF, comparison of EMF, as well as the internal resistance of a cell or battery also. Okay, note down this. So R equal to SL divided by 1 minus L. Here L is known, so definitely we will get 1 minus L also, and the standard resistance S is also known. So then easily we can calculate the resistance of unknown resistor. Okay, so it is this one is the practical application of Redstone's network. Okay, is it clear? See, so what happens if we interchange the unknown resistance and the standard resistance? Suppose if you connected in the left gap, here in this case we have connected the unknown resistance in the left gap and standard resistance in the right gap of a middle bridge. I will show the middle bridge. Okay. So what happens if you interchange these two? If you interchange these two, so then we can write the resistance equal to 1 minus L. Just you have to interchange this. So 1 minus L into S divided by L. Remember, if you interchange these two, it means in the left gap of the middle bridge, if you connected standard resistance, and in the right gap of the middle bridge, if you connected the unknown resistance, then we can write R equal to 1 minus L divided by L into S. Okay, and here L must be in meter. If you use, if you want to measure, or if you want to take the length in terms of centimeter, so then we can write this relation as S into L divided by 100 minus L. So instead of 1 meter, you have to use 100 centimeter. So S into L divided by 100 minus L. And here also same, 100 minus L divided by L into S if L is in centimeter. If L is in meter, directly we can write SL divided by 1 minus L. Is it clear? Okay. I will show how that middle bridge. So this one is the meter bridge. Ready? Here this point is, you can call it as A, and this point is B, C. Okay, so here this one is the left gap. This left gap is, that is A and B. Okay, so here also same connections. You can take B here, here, or here. Both are same. Okay, this one is the left gap. So here you have to connect the unknown resistance, and this one is the right gap. Okay, here you have to connect yes, and this one is the middle bridge, and here middle. So this point is the B. Here you have to use you have to connect the galvanometer. Okay, here from B to galvanometer and galvanometer to jockey. Okay, and by connecting here to here, A to C, one cell. Okay, and by adjusting the length, it will showing zero diffraction. So that one is the null point where we'll get the zero diffraction. At that point you have to take it as the D, and from one end to that point D easily we can will get, because simply it is a meter scale. See here the scale is in centimeter. Suppose here we are getting null diffraction, so it means by keeping this galvanometer is here, means the pointer is here, the galvanometer showing zero diffraction. If the jockey is, the position of the jockey is here, so suppose it is 35 centimeter and remaining is 65 centimeter. Here it is L, clearly here you will get 1 minus L or 100 minus L. So that L you can write in terms of meter, and easily we can calculate the unknown resistance of the wire by using this meter bridge. So this one is the practical application of Redstone's network. Okay, thank you.